Dear students, myself I am Mamta Devi AB, Assistant Professor of Chemistry. In this video, I am going to explain session 49 of spectrophotometry and photochemistry. The contents of this video are explanation with example of photosensitization, photoinhibition, fluorescence, phosphorescence, chemiluminescence and bioluminescence. Photophysical processes. All the light absorbed is not effective chemically. Some amount of it may be converted to heat and some may be re-emitted as fluorescence or phosphorescence. Thus, these are the processes in which a substance absorbs light without undergoing any chemical change. It is called as photophysical processes. Various consequences of photophysical processes are explained in the subsequent slides. Photosensitization. Some molecules which ordinarily do not undergo any photochemical reaction by the absorption of light of a particular wavelength. Such molecules are made to undergo photochemical reaction in presence of substances called photosensitizers, which acts as a carrier of energy. So, photosensitization is the process of initiating a reaction through the use of a substance capable of absorbing light at that particular wavelength and transferring the energy to the desired reactant. Example, photosynthesis in plants, dissociation of hydrogen molecule. Photosynthesis in plants. Photosynthesis of carbohydrates in plants from carbon dioxide and water, in which chlorophyll, the green coloring pigment, acts as a photosensitizer. Here, chlorophyll absorbs visible light of wavelength in the range of 400 to 700 nanometer. The energy of the light absorbed by chlorophyll is transferred to carbon dioxide and water molecules, which then reacts to form a carbohydrate such as cellulose or sugar. Dissociation of hydrogen molecule. Hydrogen molecule doesn't undergo photochemical dissociation by absorbing UV light. Here, mercury acts as a photosensitizer. Mercury absorbs energy to form an activated molecule, as in the step 1. This activated molecule transfers its energy to hydrogen molecule to undergo dissociation to form hydrogen atoms. That is step 2. Photoinhibition. In certain photochemical reactions, some substances are able to reduce the rate of a photochemical reaction by decreasing the formation of free radicals, which normally acts as a chain carriers. Thus, the phenomenon of retarding the rate of a photochemical reaction by using some substances is called photoinhibition. The substances which reduces the rate of a photochemical reaction are called photoinhibitor. Example, traces of nitric oxide, sulfur dioxide or oxygen acts as a photoinhibitor in the photochemical combination of hydrogen and chlorine. Fluorescence. We know that a molecule after absorption of energy get excited and moves to higher state and can remain there only for about 10 to the power of minus 8 seconds. Within this time, if the molecule does not get deactivated by some means, then the whole or part of absorbed energy is re-emitted as a light. But emission of light stops as soon as the incident radiation is cut off. Thus, the phenomenon of instantaneous emission of visible light by an excited atom or a molecule is called fluorescence. The substances which exhibits fluorescence are called fluorescent substances. Example, diamond. Other examples for fluorescent substances, rubies, emeralds, diamonds exhibit red fluorescence under long wave UV. A solution of chlorophyll in ether shows blood red fluorescence. In the given slide, fluorescein, rhodamine, rhodamine 6G, fluoride, calcium fluoride, quinine, mixture of quinine and rhodamine, uranium, petroleum, etc. also exhibit fluorescein. The applications of fluorescent substances are these are used in traffic signals, finding adulteration of foodstuffs, dials of watch and timepiece, fluorescent microscope, etc. Phosphorescence. Certain substances, when exposed to radiation, absorbs energy and continues to emit visible light even after the incident radiation is cut off. It is delayed fluorescence. Thus, the phenomenon of emission of visible light for a short time from the substances even after incident radiation is cut off is called phosphorescence. The substances which shows phosphorescence are called phosphorescent substances. Example, zinc sulfide. The other examples for phosphorescent materials, they glow in the dark toys, stickers, paint, wristwatch and clock dials that glow after being charged with a bright light, such as in any normal reading or room light. Zinc sulfide, alkaline earth metal sulfides, many fluorescent substances, when dissolved in fused boric acid or glycerol, show fluorescence. The fluorescence and phosphorescence is explained by Jablonski diagram. Fluorescence is instantaneous emission of electronic transition from singlet to state S1 to ground singlet state S0, that is singlet to singlet. That means the fluorescence is caused by the electronic transition of the electrons between two states having same spin multiplicity. Phosphorescence is low because transition from triplet state to singlet ground state is slow, that is singlet to triplet. Thus, the phosphorescence takes place from the electronic transition of the electron between two states having different spin multiplicity. Chemiluminescence. It is the phenomenon of emission of visible light by a chemical reaction at normal temperature. It is thus the reverse of photochemical reaction. This is also called as cold light. The substances which emit radiations during chemical reactions are called as chemiluminescent substances. Examples for chemiluminescence are glow of marsh phosphorus is visible in dark, light of glowworms and fireflies, oxidation of some Grignard reagent give characteristic light. Bioluminescence. The emission of light by living organisms or in biological reactions are called as bioluminescence. Example, cold light emission by glowworms like fireflies. It involves the oxidation of luciferin by atmospheric oxygen in the catalytic presence of an enzyme called luciferase. The luminescence observed at night in the ocean is probably due to the decay of the luminous jellyfish. If you want to study more about these topics, please refer Physical Chemistry by Atkins, Physical Chemistry by More, Principles of Physical Chemistry by Puri, Sharma and Patania, Essentials of Physical Chemistry by B.S. Bal, G.D. Tuli, Arun Bal, Elements of Physical Chemistry by Puri, Sharma and Patania. Thank you.